You know, jewelry design has always been this amazing blend of artistry and incredible precision. But what if you could take a design, a sketch, and turn it into a dynamic, living blueprint? Well, today we're going to dive into a really powerful digital technique that's making that possible: parametric design. So let's start with the big question, the fundamental challenge for any jeweler working in the digital world. Imagine you're trying to lay down a perfect repeating pattern, like tiny gemstones or some intricate texture, onto a beautiful, organic, flowing shape. How in the world do you keep that pattern perfect when the surface itself isn't flat? And this, right here, just nails that core problem. On the left, you've got the soul of jewelry, right? It's artistic, it's organic, it's free-flowing. But on the right, that's the reality of how things are made today. It's mathematical, it's precise, down to the tiniest fraction of a millimeter. So the real question is, how do we bridge that gap without losing all that artistry? To answer that, we've got to first really get a handle on this precision challenge. It's all about making that leap from pure art to a functional algorithm. I mean, think about classic techniques like pavé, where a surface is literally paved with gems, or granulation, where you have hundreds of tiny little metal beads that have to line up perfectly. Traditionally, that's the job of a master craftsman with an incredibly steady hand. Now, trying to get that same level of perfection onto a digital curve, that is the challenge. So the solution actually begins with understanding the canvas itself, the digital surface where all these amazing designs come to life. Okay, so there's this key term, NURBS surface. Now, it sounds super technical, I know, but it's really just the mathematical language that computers use to describe any 3D shape you can think of. From a simple, flat plane to the most complex, curvy, organic form, it's basically our digital clay. And the absolute best way to think about a NURBS surface is like a flexible piece of digital graph paper. Every single point on that paper has its own unique address, and that address is defined by two values, U and V. Think of it just like longitude and latitude on a map. This idea is absolutely crucial for what we're about to do next. All right, so we've got our digital canvas. Now, let's take a look at the specialized toolkit that makes this incredible level of precision not just possible, but practical. Let me introduce you to AlgoJewels, or AJ for short. It's a specialized set of tools that runs inside a visual programming environment called Grasshopper, which itself is a plugin for the super popular 3D modeling software, Rhino. But here's the most important part. It was made by jewelers for jewelers. It's designed to solve their very specific real-world problems. So at its heart, AlgoJewels is a parametric engine. What on earth does that mean? Well, instead of creating a static, fixed 3D model, like a clay sculpture that's finished, you're creating a dynamic recipe. Just look here. You can change one little thing, like the ring size, and the whole design, the thickness, the gem positions, everything, it all updates automatically. Your design isn't a dead object anymore. It's a living set of rules. Okay, so how do we actually use this parametric power? Well, the key, the real secret sauce, is learning how to map your design by isolating a very specific area on your surface where you want to add all those little details. The main idea is this. Before you can just start covering an area with gems or textures, you have to tell the software exactly which area you're talking about. You need to draw a boundary. In the world of Grasshopper, this is called defining a domain or extracting a subsurface. And this is exactly how you do it. Remember those U and V addresses we talked about? The digital longitude and latitude? Well, the tools inside Grasshopper, like the ones you see right here, let a designer literally punch in a range of U and V values to select a very specific patch of that digital graph paper. So the whole process really just boils down to 3 simple steps. First, you select the overall surface of your model. Second, you define that specific domain by setting the start and end points for your U and V coordinates. And third, you use a component to basically cut out and extract that specific patch, that subsurface, which is now all prepped and ready for you to work on. All right, let's get to the fun part, the payoff. After all that technical setup, what can we actually create? This, my friends, is where the magic really happens. This subsurface technique has so many amazing practical uses in jewelry design. You can use it to perfectly map out where every single gemstone goes in a pavé setting. You can create these incredibly precise channels for mill-grain details. You can apply a specific texture to just one part of a ring, create beautiful etched patterns, or even align the path for a cutting tool. The level of control is just incredible. For example, check this out.
Once that little subsurface is defined, a designer can use a tool like the kaleidoscope component in AlgoJewels to automatically and perfectly arrange repeating things, like gemstones, filling that specific area and nowhere else. It completely takes all the guesswork out of the equation.
And it's not just about placing objects either. You can also take a really complex, flat, two-dimensional pattern and just flow it, almost like liquid, precisely across that 3D subsurface you defined. This is absolutely perfect for creating intricate filigree or engravings that follow the contour of the jewelry exactly. So let's zoom out for a second and just look at the big picture here. What does this massive shift towards parametric design really mean for the future of jewelry? This quote from the creators of AlgoJewels really just sums it all up. The entire industry is moving away from making single, static 3D models. The future is all about creating these adaptable, intelligent design systems. What this all means is that this technique transforms a design from a fixed object into a living, adaptable recipe. It gives designers an insane amount of efficiency, incredible precision, and the creative freedom to generate endless variations of one core idea, all while keeping the craftsmanship at the highest possible level. So, this really leaves us with a final thought. When that barrier between a really complex idea and its perfect execution just disappears, and your design becomes a dynamic, adaptable recipe, what new forms of beauty are you going to create?